Yeah, so this is the demo of the project. So we can see we can get a quotation from here for a Sol and USDC pool. This will give us the DEX, the price, the best price between the two, and the estimated output that we will get. We can execute orders. So this is a order. We can check the status of this order from this API. Confirmed the DEX on which it was confirmed, the price, and every other detail. We can get the transaction hash, the price, the difference between the quoted price and the executed price, if there was any slippage, what's the error, and if the transaction requires wrapping. Wrapping is when one of the currencies is native. Then these are for recent orders. One functionality, the concurrent orders test. So for this, what I'll do is I'll send a lot of concurrent transactions. I will say let's say 25 transactions at once. So as these get processed, I will set a search here. Okay, so we can see the 25 orders. They got confirmed pretty fast. Let's just see if, yeah. So yeah, so we have 26 rows. All the transactions have been confirmed almost immediately. We have implemented queuing and the features using Redis. It's in this folder. In services, yeah, queue.ts and redis.ts for caching. You can look at the code there. We have also implemented tests, so you can see the test. The test uses the Jest library on. This will take around 30 seconds to run all the tests, but while we are waiting for that, I can walk you through the architecture. It slows down the system a lot. Okay, there's an empty test suite there. I think that's just got left. Yeah, that's not a valid test anyway. But the main 3 test suites, they pass. Alright, so this is my architecture. There is an app. We submit an order using that app. The API, it collects the order and then it passes it to the queue, which Redis indexes, and it keeps in the cache. Then the order history, the trails, and if we want to do any analytics of whatever orders and that stuff, we can get it from Postgres, the database. There's WebSocket implementation to get faster queries, and yeah, I think that's it. Oh, I'll also demonstrate these functionalities. I think these were remaining. So we can see queue stat. I think there are no orders in the queue right now, so we won't get anything. But this gives us the total waiting, active, completed, failed, delayed, all of these details. With system metrics, we get the total number of orders by DEX. So we can see it's a 50-50 split. 13 were taken by this and 13 were taken by this. The success rate for both is pretty good, but we get the total volume that both of them processed, 325, 400, the average slippage for both of them, and the number of transactions which involved slipping. This is the time range overall success rate because all the transactions went through. The Q statistics involved, I think, some failures from the earlier testing criteria. I have reset the database since then. So yeah, I think this is it. This is my project. Thank you.